Hello student, today we are going to study the inverse of matrix by elementary transformation. Let us recall inverse of matrix. If A is a square matrix of order M and if there exists another square matrix B of the same order such that AB equal to BA equal to I, therefore B is called as the inverse of A and it is denoted by A raised to minus 1. And we also know that the inverse of matrix, if it is exists, can be obtained by using two methods. First method is nothing but adjoint method and second method is nothing but elementary row transformation or column transformation. Now in previous lecture we discussed about the adjoint method. Today we discuss about the inverse of matrix by elementary transformation method. Inverse of non-singular matrix by elementary transformation by the definition of A. If A inverse exists, then A into A inverse equal to A inverse A equal to identity matrix. Let us consider the equation A into A inverse equal to I. Here A is a given matrix of order M and N is an identity matrix of order M. Hence only unknown matrix is A inverse. Therefore, to find A inverse, we have to first convert A into the identity matrix, that is I matrix. This can be done by using the elementary transformation. And we know that how to convert A matrix of order 3 into the I3 matrix. If we use the row transformation, therefore, there are 6 steps can be follows. First step is nothing but reduce A11 position elements is 1. Second step A21 position reduce A21 position and A31 position to 0. Third step reduce A22 position elements to 1. Fourth step reduce A12 and A32 position element to 0. Fifth step reduce A33 position elements to 1 and last sixth step reduce A13 and A23 position elements to 0. If we apply the column transformation, therefore you we can use the following step. First step is nothing but reduce A11 position elements to 1. Step second reduce A12 and A13 position elements to 0. Third step reduce A22 position elements to 1. Step 4 reduce A21 and A23 position elements to 0. Step 5 reduce A33 position elements to 1 and last step 6 reduce A31 and A32 position elements to 0. If we decide find the A inverse by row transformation, therefore we consider A into A inverse equal to I, this equation, and applying the row transformations on A matrix and A convert to the identity matrix using the elementary transformation, row transformation, and this transfer simultaneously apply on I matrix, that is identity matrix. A convert to I matrix, A inverse remains same and this I matrix convert into the new matrix. Therefore, properties of identity matrix written as A inverse equal to B. Therefore, we get the A inverse matrix. Similarly, if we decide use, use the column transformation, therefore first we can write the equation A inverse into A equal to I and apply the elementary column transformations on the A matrix. Simultaneously, this operation also apply on the identity matrix. A matrix convert into the identity matrix. A inverse matrix remains same and this identity matrix convert into the new matrix and which is nothing but inverse of A matrix. In this way, we discuss the row transformation and column transformation. Now, let us see the examples on inverse of matrix by elementary transformation. For example, if A equal to matrix of order 3, first row elements 2, 0, minus 1, second row 5, 1, 0, third row elements 0, 1, 3, then find A inverse by elementary row transformation method. Solution. First, find the value of determinant of A. And determinant of A is written as two vertical line. First row elements is nothing but 2, 0, minus 1. Second row elements 5, 1, 0. Third row element 0, 1, 3. And simplify this determinant of order 3 by A11 position elements 2 in bracket. Delete first row and first column elements. Therefore, 1 into 3 is nothing but 3 minus 0 into 1 is nothing but 0. Delete first row and second column elements. Intersecting elements is nothing but 0, right? And 5 into 3 is nothing but 15 minus 0 into 0 is nothing but 0. Next, first row and third column deleted. Therefore, intersecting elements is nothing but minus 1. And in bracket 5 into 1 is nothing but 5 minus 0 into 1 is nothing but 0. And simplify this expression. 2 into 3 is nothing but 6, 0 into something value is 0, minus 5 minus 1 into 5 is nothing but minus 5, 6 minus 5 is nothing but 1, and value of determinant is equal to 1, which is not equal to 0, that is A is non-singular matrix, therefore A inverse exists. And find the A inverse by row transformation, therefore we can consider the equation by definition A into A inverse equal to I. And substitute the value of A matrix. Value of A matrix, first row element 2, 0, 1, second row element 5, 1, 0, third row element 0, 1, 3 into A inverse equal to, and substitute the value of identity matrix of order 3 because A is a matrix of order 3. And we know that identity matrix of order 3 is nothing but 1, 0, 0, 0, 1, 0, 0, 0, 1 in this way. We use the elementary row transformation. Apply the step 6. First step is nothing but reduce A11 position elements to 1. That is, convert these two elements into the 1 elements using the operation R1 divided by 2. First row, each elements of R1 divided by 2, that is 2 into 2 is nothing but 1, 0 into 2 is nothing but 0, minus 1 into 2 is nothing but minus 1 upon 2. And second row and third row elements remain same into A inverse equal to, operate this operation also on I matrix. Therefore, 1 into 2 is nothing but 1 by 2, 0 into 2 is nothing but 0, 0 into 0 divided by 2 is nothing but 0. Again, R2 and R3 remains same. Next step, convert A to 1 positions elements 0 and A3 1 position elements 0. Now, these 5 elements convert into the 0 using the operation R2 minus 5 times R1. Therefore, R1 and R3 remains same, 1 0 minus 1 by 2, 1 0 minus, and R3 row elements 0 1 3 0 1 3. Similarly, R1 and R3 remain same of I matrix also, 1 by 2 0 0 0 0 1, only changing the R2 row, that is R2 elements is nothing but 5 minus 5, and corresponding elements of 5 is nothing but 1, and simplify this equation we get value is 0, write this 0. Second elements R2 elements is nothing but 1 minus 5 and its corresponding elements is nothing but 0. that is 1 minus 0 is nothing but 1. These elements written as 1. And third elements, R2 elements is nothing but 0 minus 5 into minus 1 upon 2. Minus into minus plus, that is 0 plus 1 by 2 written as 1 by 2. 5 by 2, sorry. 5 into 1 by 2 written as 5 by 2. This is. Similarly, operate this operation on I matrix also. That is 0 minus 5 into 1 by 2 written as minus 5 by 2. This element. Second elements 1 minus corresponding element is 5 into 0 written as 5. And both are 0, therefore these elements also we and convert. Next step, a 2 positions elements 1. These elements already here. Next step, convert a 2 positions element 0. These elements also already here. Therefore next step, a 2 elements convert into the 0 using the operation R3 minus R2. R3, that is first row elements and second row elements remain same. 1 0 minus 1 by 2, 0 1 5 by 2, 0 1 5 by 2. In this side also 1 by 2, 0 0, R2 row elements minus 5 by 2, 1 0 remains same. Only changing the R3 elements. R3 minus R2. That is 0 minus 0 is nothing but 0. 1 minus 1 is nothing but 0. 3 minus 5 by 2. That is 6 minus 5 by 2 written as 1 by 2. Therefore, this elements is nothing but 1 by 2. A inverse remains same. R3 element 0 minus 5 by 2. That is plus 5 by 2. These elements. Similarly, R3 element 0 minus R2 elements, that is minus 1. Next, R3 elements 1, R2 element 0, that is this value is. Therefore, next step, convert A3 positions element to the 1 using the operation 2 into R3. That is R3 changes to 2 times R3. We can multiply by 2 each elements of R3. We get 1 0 minus 1 by 2, 0 1 5 by 2. 2 into 0 is nothing but 0. 2 into 0 is nothing but 0. 2 into 1 by 2 is nothing but 1. R1 and R3, R2 remains same, that is 1 by 2, 0 0 minus 5 by 2, 1 0 remains same. 2 multiply by R3. 2 into 5 by 2, 2 to get cancel only 5. 2 into minus 1 written as minus 2. 2 into 1 written as 2. Next step, A1 3 elements and A2 3 elements convert into the 0. A2 3 position elements, that is 5 by 2 elements, convert into the 0 using the operation R2 minus 5 divided by 2 R3. Means only changing R2 elements. R1 and R3 remain same. Using this operation, we get first row elements 1 0 minus 1 by 2, second row element 0 1 0, third row element 0 0 1 into A inverse at it is equal to, in matrix, first row elements 1 by 2, 0 0, second row elements minus 15 6 minus 5, third row elements 5 minus 2 2. Next, A1 3 position elements convert into the 0 using the operation R1 plus 1 by 2 into R3. R2 and R3 elements same, that is 0 1 0 0 1 0. 0 0 1 right same as 0 0 1. In this side also R2 and R3 elements same, only changing the elements of R1. R1, that is 1 plus 1 by 2 into 0 is nothing but 1. 0 plus 0 plus 1 upon 2 into 0 value is nothing but 0. R1 elements minus 1 by 2 plus 1 upon 2 into 1, that is minus 1 upon 2 plus 1 by 2 is nothing but 0. Therefore, the matrix written as 1 0 0 0 1 0 0 0 1 into the A inverse equal to first row and second row elements written as same, only changing the R1 elements, that is 5 R1 elements 1 upon 2 plus 1 upon 2 into R3, we get value is 3. Similarly, these elements are R1 element 0 plus 1 upon 2 into minus 2, that is minus 1. And this elements is nothing but 0 plus 1 upon 2 into 2. We get 1. Therefore, this matrix written as I matrix, identity matrix. That is I into A inverse equal to in bracket first row elements 3 minus 1 1, second row elements minus 15 6 minus 5, second row elements 5 minus 2 0. In this way we can solve the inverse of matrix non-singular matrix by elementary row transformation method.